Okay, I'm going to jump down and solve E next. So if you haven't done A, B, and D, you can go back and do them in just a minute, but I'm going to jump down and solve E. There's more than one way to solve it, but I would like for you to solve it this way, and it'll make sense a little later on. But first thing you're going to do is rewrite it exponentially. So I have n to the 2/3 power equals the cube root of 49. Now because I've raised n to the 2/3 power, I have that written as a fractional exponent. I'm going to go ahead and write 49 with a fractional exponent. Because remember, cube root, that bottom in the crack, is the same thing as the 1/3 power, right? So I'm going to do n to the 2/3 power equals 49 to the 1/3 power. That's just another way of writing the cube root of 49. Now the reason I did that is because it makes it easy to solve. Because do you remember how we got rid, because I need to get n by itself, so I need to get rid of this 2/3 power. Do you remember how we did that? On that,
switch it.
Exactly. You multiply, or you raise it to the 3/2 power, the reciprocal power. And if I do this to the 3/2 power, I have to do this to the 3/2 power. Okay, so over here, the 3's and the 2's cancel and leave you just n, which is exactly what you want. And on the right side, what happens to the 3's? They cancel and leave me 49 to the 1/2 power. Well, what is the 1/2 power? Square root of 49. So the answer is actually 7.
Oh, what's happening?
Okay, and the reason that I would like for you to, there are other ways to do this, and amongst them is guess and check, but the reason I'd like you to do it this way is because, remember, a logarithm is an exponent. So instead of writing things as roots with radicals, we're going to write them as exponents. You're going to have to rewrite them with fractional exponents. So you kind of need to get used to that. All right, I'm going to do F, and then we'll jump back and do C, because I think once we do F, C will make more sense. Okay, so on F, the first thing I'm going to do is rewrite it exponentially. So I'm going to write 9 to the n power equals 27. Now, on the ones up above, I was just able to go, okay, well, what power do I raise it to in order to get 27? But 9 squared is already 81, which is too big to be 27. So I have to try and figure something else out, because I can't figure out off the top of my head what power to raise 9 to in order to get 27.
3.
Hold on. Yes, but don't guess and check, because there's a way to do it. See? And we need to remember how to do it. Because our last unit, if we could find like bases, then we could set our exponents equal. I can rewrite 9 as a base of 3. How would I do that?
3
squared.
3 squared. So this would be 3 squared, and the n was there, so I have to leave it there. And I can write 27 with a base of 3.
3 to the 3rd.
3 to the 3rd. Now what happens when your bases are the same? They cancel. And so you're left with just 2n equals 3. So n equals 3/2. Which I know you got from guessing and checking, but I figured it out and didn't have to guess and check.
It's on the front.
Yeah, I saw it on the previous
Oh.
problem, so I know what this is.
All right, now C is similar. So the first thing we're going to do is rewrite it. I'm going to rewrite it as an exponential problem. So I'm going to write 1/2 to the n power equals 64. Now, I cannot think of a way that I would raise a half to any power and get 64. Because if I square a half, I get a 4th. If I cube a half, I get an 8th. No matter what I do, my fraction gets bigger. I don't get a bigger number. But I could write 64 as a base of 2. And that would get me closer. 2 to the what power is 64? You may know?
4? No. I got 6.
2 to the 6th power would give me 64. Now, I don't have like bases yet. But I could move that 2 downstairs. And then that would be 1/2, wouldn't it? But what happens when I move him downstairs? He gets negative. He gets really upset. And one on the left stays 1/2 in. This is going to become 1/2 in, but now he's angry to the -6th power. Well, now you have like bases. So if my bases are the same, they cancel out and you're left with just your exponents. I got n equals -6.
When you flipped it, it changes the exponent? Right.
Yeah, that's what, remember, whenever you move the base from downstairs to upstairs, it makes the exponent angry or not. Negative or not. All right, we're going to skip problem 5. We're going to skip those and move on to the exponent properties. We're not going to fill in the top part because you've already done that. You have this page that we just filled in, the log properties, and that's all that is. It's just doing that again. So we're not going to do that. We're going to skip down to problem number 1, where we're going to use the log properties. So you might want to have that log properties page out, just so that you have them right in front of you. We're going to use the log properties to both expand and condense. So we're going to use them to make the problem bigger and to make it smaller. The first thing we're going to do is we're going to use it to expand. Write this in expanded form. So currently I have one logarithm, and inside my argument I have a 6 times an x to the 5th. I want to expand this one logarithm into multiple logarithms. So if I have an argument that's being multiplied, 6 times x to the 5th, how do I expand it? Add it. So I'm just going to separate this out, and it's going to become log base 4 of 6. That's my first piece. Plus log base 4 of x to the 5th. Now you're not finished, because in this expansion, yeah, I've got this 5 up here, and I need to use my power rule and move it to the front. So I've got log base 4 of 6. Nothing happens on that one, but on this one, the 5 gets to move to the front. And you have 5 log base 4 of x. So that's your final answer. That's the expanded logarithm. You okay?
Sure.
Alright, so these are just a little more complicated than the ones we did on the log properties page, because they have multiple things happening. So if you look at B, on top I have a 3 and a y. What operation's happening between the 3 and the y? Multiplication, right? They're being multiplied. But what about the x?
It's divisioning.
It's division. So I have multiplication and division in this problem, which means when I expand it, I'm going to have adding and subtracting. So let's see. The first thing I'm going to do is write out log base 7 of 3 plus log base 7 of y to the 4th minus log base 7 of x to the 3rd. Now you're not finished because I have those 2 exponents that can be moved to the front. So I've got log base 7 of 3 plus, now this 4 gets to move to the front. So 4 log 7 of y minus 3 log 7 of x.
This is great.
And that's it. Everybody okay? Now C looks more complicated because it's natural log, but it's not any more complicated. That just means it's log base E. And in this case, so far I've done nothing to my bases. They just carry along. You don't have to do anything to them. And this is no different. You're not going to do anything to the natural log. Inside I have a 3, an x, and a y. They're all being multiplied.
So there'll be 3 of them?
So there'll be 3 pieces. Log 3 plus natural log x plus natural log y to the 3rd.
I pick up that
And then I got to fix that 3. So natural log of 3 plus natural log of x plus 3 natural log y.
You don't have to write any other.
Nope. So that's it.
Understood.
This is the answer to that one.
Oh, are we compressing these next one?
Yep. So that's how you take one logarithm and make it into an expanded logarithm, which sometimes we have to do in order to solve it. But sometimes in order to solve it, we have to condense the logarithm. So we go backwards. So for this one, I have 2 logarithms separated by addition, which means I'm going to put them back together with multiplication. So before I do that, I'm going to fix the 3, move it back where it belongs, so it goes up there with the x to the 3rd. So I'm going to have log base 2, 10x to the 3rd. Y'all okay? Okay, this one is going to be, I'm going to move the 4, both of the 4s. There are 2 logarithms separated by subtraction. So you'll be dividing, so it's going to be log 12 to the 4th divided by 2 to the 4th. That simplifies. You can put it in your calculator to simplify it. It's a big number. If you think about how big 12 to the 4th is, then you'll know it's a big number. I think it's 1296. You can just plug that in your calculator and it'll simplify it for you. Pretty sure it's 1296. All right, and then the last one. Now this one's a little trickier. Not because it's natural log, but because it's got all these pieces. So the first thing I'm going to do, these are grouped in parentheses because of that 3 in front. So that implies to me that the 3 belongs to both of them. Now I'm going to write out this step. You don't have to write it out, but I'm going to distribute the 3. So it's going to be 3 log 3 minus 3 log x. And then this piece is plus log x minus log 9. That part was grouped together, but it's not necessary, so I just dropped the parentheses there. Now I can take each of the individual 3's that's in front, these 3's, and put them where they go. So this 3 goes over here.
3 to the 3rd.
So this is going to be log 3 to the 3rd minus log x to the 3rd. Yes? Yes, ma'am. Uh-huh. That's awful. Plus log x minus log 9. Okay, now, I don't want this to throw you off, but we already know anything that's addition is multiplication, right, when we put it back together. And anything subtraction is division. And I have both multiple times. So what I'm going to do is I'm going to go ahead and group them. You won't have to do this step either once you get used to it, but I'm going to put all of my subtraction pieces together. And because it's division, the subtraction goes at the bottom, so I'm going to put them at the end. So I'm going to rewrite this as log 3 of 3 plus log x. That was my these positive pieces. They're together. Now minus log of 3, log x to the 3rd minus log of 9. So I put my 2 subtraction pieces together at the end before I rewrite this. All right, so that means these are separated by addition, which means they're going to be multiplied and on top. I'm going to go ahead and work it out. What is 3 to the 3rd?
9. Chicken,
27.
27.
Chicken.
But it sounds like, wait, 3 to the 3rd.
And then on bottom, both of these are going to go on bottom. I'll put the 9 first because we like coefficients to be in the front. 9x cubed. That simplifies because 27 over 9 reduces. And the x's will cancel, so I end up with 3 over x squared. Now, once you get used to it, you don't have to write out all those steps, but I want you to understand exactly what I'm doing before you just skip it. Okay, so we're going to practice condensing and expanding logarithms. So you're not doing this whole worksheet, no panic. The problems that you are doing are on the board.
So we're caught up now.